Beyond the headlines, Unmasking AI Bias. See it, fix it, build fair AI. You've heard the headlines, AI is biased. But what does that really mean? And more importantly, how did a machine built on logic and data become prejudiced? Today, we're pulling back the curtain on AI's hidden biases, showing you exactly how they emerge and equipping you with the knowledge to demand and build a fairer future. Let's begin with a common scenario, a seemingly neutral dataset for a hypothetical job application. Watch closely as an AI learns from this information. You'll see how, even with subtle imbalances in the initial pool, perhaps more positive outcomes for male candidates or those from certain universities not explicitly tied to qualifications, the AI disproportionately weights features, leading to prejudiced decisions. This demonstrates historical bias, where AI learns from past human choices that contained ingrained unfairness, or sampling bias, where data for minority groups is insufficient or unrepresentative. We'll also expose proxy bias, where seemingly neutral features like zip code or name pronunciation unintentionally act as stand-ins for protected characteristics. Next, consider a simplified facial recognition system. Imagine it's trained predominantly on lighter skin tones. When diverse faces are introduced, you'll observe how the AI's confidence score or feature detection falters dramatically with darker skin tones or less represented features, leading to misidentification or failure to recognize. This reveals algorithmic biases, where models underperform on unseen data from underrepresented groups. It also highlights feature engineering bias, where human decisions about important features unintentionally bake in unfairness, and the challenge of the black box, the difficulty in understanding why an AI made a certain decision, which obscures hidden biases. The problem often spirals. Picture an animated cycle. Initial bias in data leads to biased AI, which then influences real-world decisions, creating new biased data, perpetuating the cycle. This feedback loop can cause real harm, evident in areas like predictive policing models or recidivism prediction in criminal justice. But there is hope. We'll enter the Bias Buster Toolkit, a solutions lab demonstrating concrete mitigation steps. First, through pre-processing techniques, you'll see data being reweighted, augmented with synthetic diverse data, or sampled fairly before AI training. Watch how these methods visually transform the dataset. Then, explore in-processing adjustments, where fairness constraints are built directly into the AI's learning process. Witness a model correcting itself as it learns to rebalance outcomes for different groups. Finally, discover post-processing techniques, demonstrating how fairness metrics are used to audit an AI's performance across various demographics, showing how fairness scores can improve. Beyond code, we'll emphasize the crucial role of human oversight and diverse ethics committees in reviewing, auditing, and making ethical decisions about AI deployment. Building fair AI isn't just a technical challenge, it's a moral imperative. By understanding where bias comes from and applying these strategies, we can move beyond the headlines of fear and instead build an AI future that serves everyone.